Welcome all, and thank you for joining today's session on winery remediation options for smoke-affected juice and wine. My name is Michael Downey, and before we jump in and make a start, a couple of very quick reminders for anyone new to AWRI webinars. To provide a comment or to ask a question, please open the Q&A section of the webinar, type in your question and click to send it through. We will be running a dedicated Q&A at the end of today's presentation, but please send through your questions at any stage. Also, the webinar is being recorded and it will be available to view via the AWRI's YouTube channel, most likely later this afternoon. Now, for those of you that have just joined, welcome. Today's webinar will discuss outcomes of trials using activated carbon and dilution to mitigate smoke taint. And it's fantastic to have the AWRI's Dr. Julie Culbert with us to share some insights around this project. Julie has worked as an analytical research chemist in both the wine and water sectors, and also worked as a postdoctoral fellow at the University of Adelaide before joining the AWRI in 2016, where her research has focused on smoke taint remediation tools. Julie, thank you for joining us today, and if you're ready to make a start, I'll hand over to you.
Good morning, everyone. Thanks for tuning in today for the presentation. Yes, I'll be talking on about some winery remediation options for smoke-affected juice and wine. So just first of all, point out that this was part of a rural R&D for a profit project that was started back in late 2016 and finished towards the beginning of this year. We reported the results to government. So we haven't actually captured anything in the current 20 vintage. So we're going to give you a bit of an outline of some of the remedial options that we were looking at for smoke exposed grapes. So whether that's from the juice or through to the final wine. So I'm really going to focus just on these two main areas. So winemaking trials that we did with carbon, so where we treated the juice prior to fermentation, and then some dilution studies that we did in regards to like a finished wine. It also would be a bit remiss if I didn't mention a couple of other areas that we had started looking into, but unfortunately we just haven't had enough time to delve deeper into these areas. But I will talk a little bit at the end just about some enzyme treatment, so using glycosidase in wine, and also distillation. I just want to point to some valuable resources that we have first and foremost. The AWRI website is an excellent resource for all information that we've got on smoke taint to date. And the stuff that I'm talking about today on carbon and also on dilution, there are actually fact sheets available on the AWRI website. So if you feel like I've gone through some of this too quickly and you want to read it in your own time and a bit slower pace, then really go to these fact sheets. It might be useful for you to refer to those. We've also got a paper that was published in the proceedings from last year's Wine Industry Technical Conference. So that's available for download as well. So that goes into the information in regards to the work on evaluating activated carbons. And also just to pinpoint, a lot of you might have already used it, but the help desk is always there as a valuable resource. So if you have any questions, you can email the help desk. So before I really get into any of the remediation trials, you have to understand a little bit about the basic chemistry of smoke taint. So if we look here, smoke actually contains a lot of volatile phenols. So anything from these guaiacol derivatives to syringol to creosoles. And so what happens is those smoke actually will get into the grape berry. Once they get into the berry, then there's enzymes there that will actually add sugars. So these could be a 5-membered or a 6-membered sugar. So it could be glucose, ramenose, those types of sugars. So as a result, we end up generating these phenolic glycosides. So these are the non-volatile forms, or what we refer to as the bound forms of those smoke compounds. Now, the reason that these become problematic is that during winemaking, sometimes the yeast can cleave off some of these sugar units, therefore releasing those volatile phenols. So you might actually taste the juice and think that maybe it doesn't taste too smoky, but you've got those compounds that are bound in these phenolic glycoside form. Just to pinpoint as well, you could get 1 sugar, 2 sugar units added, so it actually becomes quite complex. But you need to just to understand the basics, be aware that there are these phenolic glycosides, and there's also potentially the volatile phenols. But what we generally find is we have more of those phenolic glycosides in the actual grapes and in the juice that's produced from those grapes. So in terms of using activated carbon, I also feel like I just need to give you a little bit of a basis about what activated carbon is, and really just to understand that it's carbon-rich material. It ends up, it's highly porous. So if you see in this photo here on the right, you can see these pore structures. So this under microscope, you can see. So what ends up happening is you have highly porous material. It's capable of absorbing organic molecules. And also it's got high surface area. So 1 tablespoon probably has the same surface area as a football pitch. So probably like an actual AFL football pitch. So you can get different forms of carbon as well. So you can get them in powder activated form here. And it comes down to the size. It's in powder form, so not surprisingly, that's where the name comes from. You can also get pellets that, you know, the manufacturers will produce it in pellet form. Generally, when these are added to a juice or a wine, they will disintegrate down into more of a powder form. You can also get granular activated carbon too, but we haven't really worked in that area. We focus more on using the powder activated carbon. So what did we actually do then? What we did is we did a whole screening process where we're able to do this in the lab, benchtop experiments where we'd take 50 mils of juice or wine, and therefore we'd add a certain concentration of carbon. So we did anything ranging from 0.5 grams per litre, even as high as 4 grams per litre. But just to be aware, going that high is extremely high. But we'd want to see what would happen to those chemical components. So on the left there, I've got a whole range of activated carbons that we assessed. And we also looked at the same ones in wine. So even though I've listed juice there, we've looked at the same ones in wine as well. So after we've done this contact time, so this is another thing, generally we'd contact for 24 hours. We did a little bit of research as well, was seeing, well, what happens after a given time of even 2 hours. But 24 hours was a reasonable amount of time. Generally, these activated carbons will work in a shorter period of time though. But in terms of logistics, 24-hour contact is normally quite reasonable. So what we could do is then analyse the compounds. So in this regards, we're looking at those phenolic glycosides, and just to pinpoint what this graph actually means, we've got the percentage remaining. So the percentage remaining to the control. So if it's at 100%, then we know there's no removal. It's still the same amount that's in the control. As we're going closer to 0, that's what we want. We're getting greater removal. So now we start seeing at 2 different dose rates here. So we've got in the black 0.5 grams per litre. We start seeing some differences now in the carbons. So we start seeing 3, 4, 5 are starting to get some removal, 9 and even 14. So we know that we are seeing differences, but once we start going to a larger quantity, so that 2 grams per litre, that is a lot more evident. So now we're starting to see, you know, the carbons, like I mentioned before, 3, 4, 5, 9 and 14 are really having good removals, because we're getting close, you know, to even down here, maybe only 10% remaining to the control or 5% remaining. So this was actually done in a smoke-affected Sauvignon Blanc juice. So just to highlight, this is a juice matrix. So what happens when we go to wine? So what we found when we go to wine is, and we've got a Sauv Blanc wine and a Pinot Noir, what we find is we're not getting quite as great removal. So this time we've just gone for the 2 gram per litre dosage rate. And what we start finding now is, if you look at the Pinot Noir, we're really not seeing much removal at all. Most of it's, you know, 80% of the control or greater. If we go to the actual white juice, we start seeing some better removal. So once again, those carbons we saw before, 3, 4 and 5, are actually being quite effective. But we can see that we just can't get to the same level of removal as what we can in a juice matrix. We thought maybe this was alcohol related and maybe some sort of hindrance of the alcohol, but we actually did dose some juice samples with alcohol and repeated the experiments, and we still found that we got the same amount of removals. So it's probably more likely to do with other polymers or pigmented polymers that might be present, and particularly in the Pinot Noir. So in a red style, we see more of those, and we see more hindrance of that carbon to be able to remove those phenolic glycosides. So just pinpointing again that those 3 were the best. So what about if we look at volatile phenols? So generally what we find with the volatile phenols is in some of the matrices, particularly the juices that I studied, that we weren't seeing high levels of those volatile phenols present. So what we had to do in this Merlot juice, which actually at the time happened to be artificially smoked because we were struggling to actually obtain some real material or smoke affected material from real smoke events. So what we had to do was actually dose in some of those volatile phenols before we did these experiments. With a Pinot Noir wine, we actually did have some volatile phenols, so we used that wine as is. In this instance, we're only using 0.5 grams per litre. So once again, we struggle more in trying to remove the compounds in a wine matrix. So by these blue bars here, we're not getting as great a removal. When we go look at the juice, we're getting much better removals. And what we might find this time around is, it might not be the same carbon that was effective at removing the phenolic glycosides that is as effective this time around. So where before we had 3, 4, and 5, which were the most effective, we can start seeing, some of these other carbons now, which are allocated, say number 7 or 8, for instance, are working more effectively. So it's just showing that there are differences between those carbons, and depending on whether you want to remove those smaller volatile phenols versus those larger phenolic glycosides, you start seeing differences. So just to really summarize what I've just said there is, it's really important to understand that not all carbons are equal. They're all different. There's going to be differences in selectivity for those free and bound phenols. So it's important to understand that, because if you go to one winery supplier and ask them for a particular carbon, or you go to another, then it may not necessarily be doing the job that you want it to do. So it's really important to understand there are differences, and you need to make sure that you're using a carbon that's fit for purpose and fit for what you want to do. So if you're looking at removing those phenolic glycosides, we need to be using the ones that actually work effectively for those phenolic glycosides. There are those wine matrix effects, not only just wine matrix effects, but matrix effects in general. So whether there is actually a juice matrix or a wine matrix, and there's differences between, even with the wine, there's differences between red and white. So once again, you could see in those slides that the dose matters. So if you're adding more, you're going to remove more. And so really it needs to be optimized depending on your juice or your wine matrix, how much you're going to add and which carbon you're going to add. And also depending on how tainted that juice or wine is as well. So if you have a lower taint, you don't need as much activated carbon. If there's higher taint levels, you'll need a greater dose. Having the pore structure there again, just showing, we've got these pore structures and just showing these differences in size of the molecules, okay? You don't have to understand the chicken wire diagrams, but just to show that there are differences in size. And a lot of these carbons will actually work by having the pore size that is very similar to the size of the molecule that's going to fit in there. So you can imagine if the pores are really small, then something like this glycol glucose glucoside is not going to fit. So it's just not going to be effective at removing it. So ultimately what we need to know is we need to know the effects on sensory, because at the end of the day, are we going to be able to get a wine that ends up being sellable or not? So what we did from these screening trials was actually able to pinpoint 2 carbons then that we took through to winemaking trials. So last vintage, or in 2019, last year, we actually were able to obtain some smoke-affected juice from Tasmania as a result of some bushfires that they had there in the Huon Valley. So we obtained a Pinot Noir and also Chardonnay. The Pinot Noir on a rosé style. So we got them in Tassie to be able to produce the juice for us, and we actually had the juice sent across from Tassie to South Australia. And so we did the winemaking trials here on site at AWRI with the help of the Wine Innovation Cluster winemaking services. So what we did is we actually did 50-litre scales. We took 50 litres of juice. We added 1 or 2 of the carbons, so either PS 1300 or CAS-PF, and we added 1 of 3 dose rates, so either 1, 2 or 4 grams per litre. And then we also had controls where we didn't add any carbon. We had 48 hours of contact time with the carbon, and then we added bentonite to help clarify that juice before we'd actually inoculate. So we made sure that we got clarified juices, we racked them off, and we then underwent the fermentation. So just a couple of the photos here, just seeing how if you go to extra carbon, you do start removing more colour, not surprisingly. So just to talk a little bit about just what the levels of taint are, and I know it's a bit hard because these values can be quite arbitrary if you don't know what's considered tainted and what not, but these are considered, you know, more high taint levels of fruit. And really this is just pointing out that if we look at the free run juice versus the juice pressings, we do get a lot higher taint levels in those pressings. So if you do have some issues with smoke tainted grapes, then it's desirable just to be using the free run juice. If you press the skins harder or you get pressings, you're going to end up generating more. So just looking at the totals, as we see here, you know, a total of 253 for the free run juice, 477 for the pressings. And similarly, we see higher levels in the juice pressings for the Pinot Noir. For our winemaking trials, we only looked at using the free run juice because we considered them tainted enough without having to blend it with any of the pressings. This is the smoke glycoside levels, so those phenolic glycosides. If you look at the volatile phenols, so those free forms of the smoke compounds, we see similar stories. So with the Chardonnay free run juice, we're only getting a total of 4 micrograms per litre versus 19 micrograms per litre in the pressings. And for the Pinot Noir free run juice, we're looking at 35 versus 47. So there are the differences there and considerations when you're going through your winemaking. In terms of looking at the removal, so first of all, I'm just looking at the removal of those smoke glycosides. So once again, we've got percentage remaining on the axes there. We've got the different dose rates of 1, 2, and 4 grams per litre. 2 different carbons, so the PS 1300 and the CAS-PF, and the 2 different juices, so the Pinot Noir on the left and the Chardonnay on the right. So what we see is when we're adding 1 gram per litre, we're starting to get about 20% removal of those total glycosides. As we go to higher levels, we're getting greater removal. And as I say, not surprising based on all our bench top experiments where we see a greater dose, we get greater removal. So by the time we're getting down to 4 grams per litre, we can, particularly using CAS-PF, we end up maybe only having about 5% of those glycosides remaining. Similarly, story for the Chardonnay, really just to point out here is that we see that the carbon's more effective in that white juice versus the red or the rosé style juice. And once again, not surprising. Not much different, a little bit of differences between the 2 carbons, but generally at the, that was only observed more in that Pinot Noir free run juice, where we start seeing these differences here. The different letters are indicating statistical significance, so there's differences. So what does it ultimately mean for the wine sensory characteristics? Because obviously that's what we're interested in ultimately, is what it means. So I'm just going to point out a couple of main areas here. So we've got this spider plot on the right hand side. We've got those compound or those sensory attributes that were considered being statistically different. And so particularly I'm going to focus on the smoke band-aid aroma and also the strawberry aroma. So sorry, I clicked on a button there and managed to go forward too quickly. But anyway, just here we're seeing that with the black line, that's the control. If we start looking at now going towards 1 gram per litre here of the PS 1300, we're starting to see that reduction in that smoke band-aid aroma. If we go further now here to 2 grams per litre of the PS 1300, we get much more reduction. But interestingly, we also see a similar level for the 1 gram per litre CAS-PF. So that's showing you we are seeing differences between the 2 carbons. So in this case, the CAS-PF is being more effective at removing that smoke band-aid aroma at a lower concentration or a lower dose, so only at 1 gram per litre. The issue starts becoming if we add too much. What we need to start looking at is this strawberry aroma, for instance, one of those desirable characteristics. So if we are only using 1 or 2 grams per litre, then we're seeing, you know, still elevated levels compared to the actual control. We start going too far, we're starting to strip out all that good aroma from the actual wine. So it's a balancing act of how much carbon do you add to try and reduce some of that smoky character by also retaining some of the desirables. And really over on the left-hand side here, which is the principal component analysis, is really just highlighting some of the things I've already said in terms of with the CAS PF, for instance. It's sitting amongst the PS 1300 at 1 gram per litre and 2 grams per litre, and we're seeing a push more towards these desirable strawberry aroma and flavour. And we're also seeing a move, therefore, away from the control here where it's all that smoke character. Now, if we go too far, there's another characteristic that the sensory panel were describing that they called cooked veg and drain aroma, which they basically said it was just the wine being completely stripped of any flavour. So this is the problem. If you go to higher levels, you will basically end up with a product that's really quite unwine-like. So you need to make sure there's a balance. So once you've done the carbon treatment, as long as you're not going at too high levels, you might still find that there's a smoke characteristic in that wine, but maybe you can start moving towards doing some other blending so that you can make sure that you're still reducing that smoke taint further, but also enhancing the desirable attributes in the finished wine that you want to put out to market. This results here, I don't think I mentioned a Pinot Noir, but we also have the results for Chardonnay. I think the results for Chardonnay are a little bit less clear cut. And I think that sometimes in terms of the sensory attributes can be quite different. So what you consider really, I found in the Pinot Noir wine, it really comes across quite smoky. You really get that smoky characteristic. Sometimes in the whites, it can be a little bit different, and it can be like a bitterness or a harshness about the actual wine. And so sometimes I think it's a little bit tricky for different individuals to be able to pick up, well, is it actually smoke tainted, or is it another attribute that is, or another fault with the wine? And so that's what we can find sometimes tasting some of these. So that's why we're pushing more workshops to be able to better educate the winemakers out there as to understanding what, you know, smoke taint actually is like, because it can be quite different from wine to wine. So here, once again, yeah, in the black, we've got the control. We start looking at the different treatments, and really we see a lot of the treatments looking very similar. So there's a few attributes, you know, the ones in the blue, the green, where we're starting to go up to more like 2 grams or 4 grams per litre. You might start seeing that cooked veg drain characteristic again. So you're really stripping the wine out. We really want to make sure that we're trying to encourage some of these more confection and floral. And I guess what's interesting in this study was that 4 grams per litre, we were actually seeing a higher level of confection and floral aroma, but that doesn't necessarily mean that the wine was any better, because we're getting the stripped, basically cooked veg drain. You're stripping it of a lot of other characteristics. So once again, over here on the left, we obviously see the control, smoke, aroma and flavour, and we're pushing more towards a little bit more citrus and flint as we go to the left. But really, if we're going to some of those 4 gram per litre, we're starting to get a bit of cooked veg and drain characteristic. And really, I find, yeah, this result here is a little bit unusual as well, where we're getting a little bit more confection with that PS 1300 at 4 grams per litre. But in no way I think you would ever want to be going to 4 grams per litre in treating your juices to that level. So in terms of the AWRI has a background database. So a lot of you out there, if you've sent samples to AWRI for analysis and for smoke taint compounds, you might have also had some interpretation done by the help desk team. And so that's on the basis of having a background database of knowing some of these compounds are present naturally in the grapes and therefore will end up in the wine. And so we've got this database for a range of different varieties and also over different regions within Australia. And so we build this database knowing that these are the background levels. So in this instance, for the Pinot Noir wine, the grey bars are actually the background levels. So this contains 99% of all the data that was obtained. And if you get a value above that, then it might be indicative that you've actually got some sort of smoke exposure, and much elevated levels, then you know that you've definitely, yeah, look like you've got smoke exposure. Our biggest problem at the moment, and what we're hoping to address with our studies that are happening now and for the next year, we'll be able to determine that grey area. because the issue is we don't know at what point we start hitting a threshold that you're going to have a problem with smoke taint. So the issue in here, just explaining this actual graph, is that I've taken, for the Pinot Noir, I've taken the control, then just with the CAS-PF, I've looked at 1 gram, 2 grams and 4 grams per litre, what the actual individual levels of 6 glycosides are, and how they start therefore comparing to that background database. So we know the more we get towards that background database, then we're probably going to have less issue in terms of having a smoke characteristic in the wine. So we know, yeah, as we go to 2 grams per litre here, you know, you start getting in that area, well, maybe less taint is detectable, but it's still kind of in that grey area where we don't know exactly, is it going to be tainted or not. We know by the time we go to 4 grams per litre, we're starting to get all these values in those grey areas or very close to the grey areas. So we know that it wouldn't necessarily be smoke tainted, but as I said before, at 4 grams per litre, we're probably going to be completely stripping any goodness out of that juice and hence out of the final product that we get. So that's why it's, as I mentioned, it's a fine balance, and we might want to start looking now at doing some blending away so that we can remove some of those phenolic glycosides so that they become less problematic, and then we start blending away. So another area that we would looking at was dilution studies. So this was taking the Pinot Noir rosé wine, so the same control wine that we used as part of the winemaking trials, and we then diluted it with a non-affected Pinot Noir wine. So we took something of similar style. We probably looked at about 8 different Pinot Noir wines to taste them first to try and match up something that was best suited to blend with the smoke affected wine. And we also made sure it was a 2019 vintage. So what we did is we did different dilutions. So we had anywhere from, it was 100% smoke affected, and then we dilute down so it was only 50%, 25%, 12.5%, and 6.25%. So down at that 6.25%, we're looking at a 1 in 16 dilution, 12.5 is the 1 in 8, and so forth. So I'm just presenting the results here of the ratings for the overall fruit flavour and the overall smoke flavour. But just to indicate, we were also rating the aroma of the overall fruit and also for the smoke aroma. So, but the results pretty much look identical. So I'm just presenting the flavour results here. So what we find is, as we have 100% of the smoke affected wine, then we're getting a reduced level of the overall fruit, not surprisingly, because you've got those smoke characters that are dominating. As we start moving towards less of the smoke affected wine and therefore more of the non-affected wine, we're starting to see now an increase in that overall fruit. And so if you look at this 1 point here, which is the 0% smoke affected, therefore meaning 100% of the non-affected wine, we start seeing that those lower dilutions, or should say higher dilutions, but only containing 12.5% or 6.25%, are really looking and hovering in the same spot on the scale as what that non-affected wine is. So we start going, well, we're not seeing the differences as much. We've been able to blend it away. On the opposite end, well, as expected, as we move from the 100% smoke affected, which we're getting a rating up here close to around 7, we therefore, whoops, trigger happy, we therefore will see a reduction in the actual smoke. So as we're going once again more towards the 100% of the non-affected wine or small amounts of the smoke, so 6.25% or the 12.5%, then we're seeing much more reduction in those characteristics. So therefore, you might end up having a wine that is sellable, that you can blend away the smoke characteristics in that wine and therefore have a sellable product. Now, obviously, this is going to be different for each individual situation because it's going to depend on the level of smoke taint that you have in that wine. And it's really comes down to a individual basis by base study where you have to decide whether you have another product that you can blend it with that you're potentially going to downgrade to mix with the smoke affected wine. So really it's a financial decision that needs to be made by each winery and whether you can end up with something that's cost benefit But the good thing, I guess, with the wine is that you're able to do small scale blends, obviously, that you can make decisions just by doing small blends. You're not using too much product, where when it comes to obviously treating the juice, you have more decisions to make, which might end up resulting in larger volumes of wine. So with the wine, you've at least got a little bit more give to play around with it and find conditions that are going to be suitable for that particular smoke tainted wine. Once again, just in regards to the background database, I'm just showing here where if we actually get down to the 6.25% or the 12.5% of smoke affected wine in that blend, then you start getting those values now towards that background levels. So not surprisingly that we're not seeing as much smoke taint in those, because we're getting back down to those background levels that we see in the database. So just another thing to point out, I've already mentioned about some of the free run juice and the pressings, but really this was just an example of being able to track some of those smoke glycosides and also the volatile phenols from grapes to juice and then onto wine. And this is something that we're really pushing towards this current vintage, is we've actually been able to generate a lot of parcels of fruit that we can therefore go from knowing what the levels are in grapes to what they are in the wine, and therefore what the sensory impact is. So we're hoping in this current research that we'll be doing is we can actually start determining that grey area. So when do the levels actually start causing taint? So in this situation, just pointing out that with the grape levels, what we ended up getting in the free run juice versus the pressings, and showing that if you're actually doing a rosé style wine. So when I say here 50 litre ferment, that was one of our controls as part of our winemaking trials with carbon. We also had about 250, 300 litres bulk ferment that we did to create extra wine for additional remediation trials. So we can see that we got good agreements, very similar levels. But if we go for a full-bodied red wine, which we did get made back in Tasmania with the same parcel of fruit, we find that we get elevated levels. So not surprisingly, if you have skin contact, you're going to encourage more extraction of those phenolic compounds, those phenolic glycosides. And also just showing that one of the wineries in Tasmania, they also generated a rosé style wine after treating their juice with carbon. So we can also see much reduced levels in those total phenolic glycosides by using carbon. Similar kind of results as well with looking at the volatile phenols. So not surprisingly, we get much more elevated levels of those volatile phenols in that full style Pinot Noir. So looking here at getting 123. And we also, it didn't matter this time in terms of whole bunch ferment, you were still getting elevated levels of those volatile phenols. But once again, much reduced levels if you were actually using activated carbon to treat the juice prior to fermentation. So they were the two main areas that we were able to focus on. And part of the issue we did have was it was really hard to obtain some smoke affected grapes and wine and juice, which is great because obviously that means that the industry is doing okay and there's not bushfires around. So we were really limited in being able to do some further investigations because really we only got suitable material 2019 from Tasmania. So we've done a little bit of work in the enzyme treatment, but it was really pushing towards the end of the project. So this is just a little bit of preliminary data that I want to present, but just highlighting that we need more work in that area because it's just not clear cut at the moment whether it's going to be effective enough. And we've only had a chance to actually look at one wine, and that was the full-bodied Pinot Noir wine. Just briefly mention about distillation as well, because we've obtained a lot of, the help desk has actually had a lot of inquiries about distillation. So what we did was we took the full-bodied Pinot Noir wine, we had a control, so that's where there was no treatment, no enzyme, no carbon. And then we had these other 9 treatments where we'd add enzyme only, and then we'd add enzyme plus carbon. And we had 4 of them where we only added carbon, so no enzyme at all. So some of these, this full-bodied Pinot Noir actually did have quite a lot of volatile phenols. So we wanted to see what the impact would be just by treating it with the carbon alone. So these experiments were performed 25 litre scale. We'd add the glycosidase at the highest recommended dose. The manufacturer performed at 25 degrees, and partly for that because we were limited for time. So we needed to make sure that it worked quicker. But all of this was performed under nitrogen headspace. And we had the enzyme contact for 8 days. So the impact on the actual total phenolic glycoside. So what we found is, not surprisingly, if you add enzyme, then you're going to encourage the cleavage of those sugar units from the phenolic glycosides. So in these five here, where we actually did add enzyme, what we find is you'll get that reduction. But we don't get complete reduction. And this is one of the areas we're still trying to get some more information about. But generally what you find with these glycosidases is they target a particular glycoside. So it tends to be the glucose. So those disaccharides where they have a glucose and a glucose. A lot of the glycosidases act by cleaving a certain linkage. So it's a 1,4 beta linkage within these sugars. So it means it's only going to target certain ones. So if we have various classes where we'll have maybe a pentose glucose, it's not as effective at cleaving those, as well as some of the monoglucosides are not as effective at cleaving those, as well as the rhamnose glucose. So we really need to better understand what the importance of each of these classes are, and it's an area that we need to do further research on. But generally what we find is most of those glucose glycosides were 100% cleaved. Where we just add the carbon alone, so these 4 here, what we find is we're not really seeing any reduction in the phenolic glycosides. And that's not surprising, because when we did the benchtop studies previously, we found we couldn't really effectively remove those glycosides in a wine matrix. And probably, as I said, a lot of competition for the activated sites on the carbon for other compounds such as coloured pigments. So ultimately, we need to know what that means in terms of the sensory side of things. And these ones, unfortunately, we didn't have time to go through like a more thorough descriptive analysis evaluation, but we were able to sit around and just talk about the ratings of the smoke taint score. So round table, we'd analyze all the wines and then had a discussion on the wines at the end. So what we actually found is that with the control, it was having a smoke taint score of 6.2. For the actual enzyme only, we were getting 6.9. Now that's not necessarily surprising, but something that needs further investigation, but not surprising in the sense that when you actually do cleave off those sugar units, you're potentially releasing high levels of those smoke compounds, those volatile phenols. And those volatile phenols are therefore contributing to the overall perception of smoke taint. When we start looking at the enzyme and the carbon treatment, we see much more bigger reductions. So if we're looking at majority of them are between, so we look at 1.5 to 3.3 was the level that we're actually seeing the taint score for those wines. I guess the other thing to point out is because it's a taint score, it's not necessarily telling you the quality score for that wine, and it's not telling you if the wine is stripped of flavour. So we know here that we can actually have an impact on the smoke taint score, but is it going to therefore be a wine that is going to be sellable to the market? And it's an area, as I said, we need a lot more research in. We need to also look at potentially looking at white wine as well. Is a possibility for white wine and maybe not just red wine, and whether we would actually get better cleavage in different matrices as well. So distillation is an area where people are interested in, and you might also be aware that there was some Hunter Valley Shiraz that went to a distillery and they were looking at making a distilled product out of it. I'm not aware of, I haven't had the opportunity to be able to taste that, so I'm not sure of the actual impact on the sensory as such, and what that product might be, or whether it's ends up being quite smoky. But we did work with one Tasmanian winery just to do a little bit of work on distillation and see what the fate of the smoke the smoke taint compounds were. So what was the fate of those smoke phenolic glycosides and those volatile phenols? So just putting a few figures on here just to show that by the time we get to a final heart distillation sample, we're basically seeing no phenolic glycosides within that product. And we're not really surprised at all with the phenolic glycosides. They're actually non-volatile compounds. So if you're doing a distillation, they're not going to come across in the distillate. In regards to the actual volatile phenols, well, once again, we're getting quite low levels here. So starting seeing values at about 68 micrograms per litre, we've reduced that down to 8 in the end for that final product. But as I say, this was really just one quick study that we managed to fit in at the end of last year, and we don't actually know the impact of the sensory. So it is an area that needs further work. So just the take-home messages for today, just knowing that we can use carbon to treat smoke-affected juice prior to fermentation. So we can reduce the smoke sensory attributes. We do potentially though see a reduction in colour depending on what carbon type we use and what dose. Just to highlight again that not all carbons are equal. So just if you get one off the shelf in one location and you go to another winery supplier, it might be completely different. Also, just to point out that the OIV recommends using carbon additions of less than 1 gram per litre. So if you start going above that levels, you might end up producing a wine that ends up being quite unwine-like. And the other thing to consider is with some of these carbons, whether there's a potential for heavy metals, for instance, to end up getting into the final product. So if you go higher levels, then you've got an increased risk of that potentially happening. But once again, that depends on the particular carbon you're using and what the source of the raw materials were for that carbon. We've also shown that dilution of smoke-affected wine with non-affected wine can reduce the perception of those smoke attributes. And just to highlight that remediation is likely to require a multi-tool approach. So I don't think that you're going to be able to say, I'm just going to use carbon treatment alone. But each situation is going to be different because it's going to be dependent on the level of taint in your starting material. But generally, yeah, you might want to do a carbon treatment in conjunction with some sort of blending as well. Just to pinpoint, as I said, more research is required in the use of enzymes and also in distillation as being a potential option for smoke-affected wine. I think in regards to distillation, it's also going to come down to demand supply. So you could send all your smoke-affected wine to a distillery, but you are actually going to have the demand for that product at the end, and that's probably something that also would need further evaluation. So just in finishing, just want to acknowledge the WIC winemaking team who did all the winemaking trials, the sensory team for sensory analysis, all the industry partners who helped guide the project, as well as those who provided material for us to do our research on, and also that the project was supported by the AWRI and through funding from the Australian Government Department of Agriculture, Water and Environment as part of its Rural R&D for Profit program and Wine Australia. And thanks everyone for tuning in.
Okay, fantastic. Thank you, Julie, for sharing results around these trials. Julie shared some of these a few weeks back in the ASVO conference, so it's great to hear a more comprehensive version of that today. Julie's also going to stick around now for a Q&A session, so if you've got any questions around any of these trials or this work that's been conducted at the AWRI, then please start sending through your questions. Open up the Q&A button on your Zoom toolbar, type it in and send it through. We've had a number of questions come in already, Julie. We'll start at the top with a comment around biochar, which has demonstrated differences in the absorption quality of carbon based on higher temperature pyrolysis. And whether you've got any comments around whether suppliers of activated carbon are able to provide such specifications.
I'm unmuted. I'll just check that everyone can hear.
Yep.
You'll find that you can get certain specifications from some suppliers. You don't always do from every one of them. Generally what you will get is what the raw material is. So whether it's like a coconut, carbon or vegetable based or coal based. You can also get some other numbers which will give you a little bit of information about the surface area and the pore size as well. So you are able to get a little bit of information, but it just depends on each manufacturer because sometimes they don't want to provide that information.
Okay, thanks, Julie. This question, I think, relates to the glycosidase treatments on the 29 treatments on full-bodied reds. Are you able to explain whether the enzyme and carbon were added simultaneous, or was this done sequentially?
Yeah, so it was done sequentially. I'm sorry I didn't point that out clearer. So we'd add the enzyme and we left it for 8 days, and then we would add the carbon afterwards. We didn't really have enough time to be able to do other trials to see whether there'd be any differences if we added both at the same time. But we just wanted to make sure that the carbon didn't interfere with the enzyme's ability.
Okay, thanks, Julie. Is there any work being done on replacement of the glycoside pool removed?
So we've had some work done in that area. So one of my colleagues, Mango Parker, and she'd definitely be one who could answer this question in better detail, but they definitely were doing some work in actually isolating some glycosides which are precursors to flavor and aroma compounds which are desirable. So they were looking at even being able to extract them out from grape marc, so that, you know, there's obviously a lot of stuff that can be left behind in grape marc, and is there more valuable material that we can obtain from it. So I know that they've been looking at doing those extractions and potentially looking at whether they could have it as an option to be an additive. So extract out these glycosides, have it as a product you could buy on the shelf, and therefore add to regenerate some of those desirables. So there's definitely been some work in that area, but it's not something that we've looked at adding to smoke affected or smoke treated material yet. But, you know, there's always a potential for doing something like that in the future.
Okay, thanks, Julie. There's also been a question about cost. Do you have any insights around cost, which is most effective in terms of cost for any of these methods?
Look, in terms of actually adding carbon, it's not necessarily a massive cost, but I think it's more the process of you will lose extra material if you need to obviously clarify and remove it, and you end up with a waste product in having the carbon. So I think generally, you know, you might add 1 or 2 cents per litre by adding the activated carbon. I think it's hard in terms of doing dilution studies, because it really depends on how much you're going to need to blend with and what particular wine that you're going to blend with, and what the value of that might be otherwise if you were just to sell it into the marketplace without blending it with a smoke taint material. So yeah, it's a little bit hard. We've done a little bit of a cost benefit analysis on it, and we actually have had our final report has been approved now by the government. So I'm hoping that means that everyone and anyone should be able to access that report, and there would be a little bit of information in there in regards to just, yeah, cost benefit, or like an economic evaluation.
Sure, thanks, Julie. Are you able to share any additional insights around why the use of activated carbon would lead to higher levels of heavy metals?
I think it's, and I'm only going by speculation, would be to do with probably the activation process as well as what the actual starting raw material is. So the activated carbon can go through a couple of different processes. So it's either a physical activation or it could be chemical. So they can actually add chemicals like phosphoric acid into into that material while therefore they're heating it up at really high levels. So we are talking at potentially, you know, they're generating them at 700 to 900 degrees. So I would say that's the basis for it, but I don't have a clear-cut answer, but that would be my speculation.
Sure. A question here about whether you're aware of any research that's been done around consumer reactions to smoke-affected wine, and is there a point or a level of smoke taint that has a positive consumer response?
We did a little bit of work with consumers. So this was very rushed once again, the end of last year when we were just running out of time on the project. And we presented wines, I think, to about 70 to 80 consumers. And we basically did the dilution study with them. So where we would give 100% of the smoke affected wine and we diluted it down, obviously, as I explained, the 50, the 25, the 12.5 and the 6.25. We might have taken one of those out actually, just for the fact that consumers don't tend to want to taste too many wines as they can get exhausted quite easily. So what we found was there were a small group, about 20%, that actually liked all the wines. So regardless of whether it was 100% smoke tainted or not. So there seems to be a percentage of the population that are more accepting of it, but I don't know what the reason for that might be. Now, is it that they're anosmic and they're just not picking up the smoke? Because we know that some people will not pick it up. Or is it that they're, I don't know, are they whiskey drinkers that love a really heavy, peaty, smoky whiskey, or do they smoke cigarettes or smoke cigars? So we haven't actually been able to pinpoint, you know, reasons for why they might. And I think if we had have actually asked a few more questions in that study, we might have got a few more answers. But hopefully, you know, as we're doing more work this year and next year as well, that we can start finding some more definitive answers to those type of questions.
Sure, thanks, Julie. Got a question here about whether the baseline database is publicly available.
It's not at the moment, but we were just talking about that internally the other day, and that we're hoping to be able to publish it sometime soon. So now that the work for the real R&D project has been accepted, I think that now will allow us to be able to publish that. So hopefully, yeah, sometime in the near future that will be available. I think the other thing to pinpoint with that, or just to highlight with that, is that you know, that's based on the analysis that we do here at AWRI. And I think the only concern is sometimes if you're going with a different commercial company for doing your smoke taint analysis, that you can't directly use our database because we're using different techniques. So we actually are individually measuring those phenolic glycosides. We're not doing a hydrolysis method and then looking at what's liberated in terms of those volatile phenols. So that's the only thing to highlight, is that obviously, yes, we have that database, but it's only going to be suitable if you're actually getting your samples analysed by AWRI Commercial Services.
Okay, thanks, Julie, for clarifying. We've got some feedback from someone who used a particular product at a dose of 0.5 grams per litre on juice, filtered off the carbon, inoculated, and then post-wine fermentation and bottled sensory showed that the wine lost a lot of its varietal aromas and characters. I suspect it's a little bit hard to make any strong comments around that without knowing more, Julie, but what would you suggest?
I guess it depends. Did they say whether it was still considered smoke tainted or?
No, there is an indication around that.
I think it just depends, obviously, on what the starting material is like. But yeah, each one's going to be different in its own right. And as I say, I don't think necessarily just doing carbon alone is going to be the answer, that you are going to have to probably blend with some other material, with other wine that makes sure that you end up having a final wine that is going to be sellable and has some sort of varietal character.
Yeah, that might be a question best addressed offline. So potentially contact the AWRI help desk if you want some further help around that one. We don't have any further questions at this stage. Julie, do you have any additional comments or or anything you want to leave the audience with before we start to wrap up?
No, but I just see another question's popped up. So,
Yep.
so is there any information on the increase in free taint compounds during fermentation and MLF were done? So in the next year, we're looking at doing a little bit more on the yeast side of things. So knowing that there might potentially be differences depending on which yeast you use. So in terms of what free taint compounds actually do arise during fermentation, I think we're really only going to start determining that now from the different parcels of fruit that we've been able to collect throughout vintage 2020 and have them go through the winemaking process where we'll actually be able to see what was in the grapes and the juice and what ends up in the wine, because it's, yeah, I've got limited information in regards to what I've looked at because I didn't come across too many smoke tainted wines, or even, you know, the grapes and the actual juice to be able to do research on. So I think, yeah, watch this space because I think we'll have a lot more useful information that's going to come out in the next year from following on from being able to get a wide range of smoke affected material in the last vintage.
Okay, thanks, Julie. I think we'll leave it there. It's probably a good spot to start to wrap up. Yeah, I'd like to first extend a really big thank you to Julie for coming in and presenting results around these trials. Some really interesting outcomes there. Thank you also to the audience who's logged in and joined today's session. Julie, could you flip to the final slide?
Yeah.
Please. Yeah, for all attendees, you'll receive a follow-up email with a link to the recording of this session. Acknowledgements also to Wine Australia for providing funding and support for webinars via the AWRI Extension Project. The next AWRI webinar takes a look at glutathione and is scheduled for Thursday, the 30th of July. So if you haven't registered for that session and you would like to do so, then please visit the AWRI website. Thank you again, and I look forward to seeing you at the next AWRI webinar.